Welcome to the course on Instrumentation and Process Control. Myself, Neeti Mehta, Assistant Professor at Chemical Engineering Department, LJIET Institute of Engineering and Technology. So, let's just start with our topic. We all know that we have started the new topic of control system before few sessions. So, let's just recall what we have covered till now, correct? So, in case of control system, we have seen how we are trying to control different operation or plant processes with the help of automation and sitting in a control panel, correct? We are trying to determine how various parameters can be controlled using a control system. What is analogy of a control system, how it actually works, and how we are relating input and output of any given system. What are various parameters which can affect the input and output of our system, correct? So, in this process only we have seen what is control system, what is basic classification of control system based on the action, correct? It was classified in open loop control system and closed loop control system. So, what happened in case of open loop control system? Whenever the output of system is not controlled by our system, then it is known as open loop control system, right? And whenever the output of our system is also being controlled by our system, then it is termed as closed loop control system, correct? So, what we are trying to say is that based on action we are performing, we can classify our control action or control system in two different categories. First one is open loop transfer function or open loop control system, in which the output given by the system is independent of any kind of control action. The example of open loop control system was washing machine, fully automatic washing machine, or toaster, or even the hand air dryer, right, where the action performed by our system is independent of the control action. The next one was closed loop transfer function or closed loop control system. In case of closed loop control system, what actually happen is we are trying to control output of our system, correct? For an example, we can talk about air conditioner. So, when whatever the input we are giving in terms of temperature, the system is trying to achieve that temperature, right? So, this is something which is being controlled. So, this was all about what we have covered till our last session. Now, in this particular session, we'll talk with some basics of control system, right? We will start with some basics of control system and deal with some rules which are quite essential to solve problems related to control system. So, let's just start. Whenever we are talking about control system, it is quite essential to know the basic definition or the basic terminologies which are being used, correct? So, first and foremost important terminology which is being used in terms of control system is block, or simply we can say block diagram, correct? So, what do we mean by block diagram? A block diagram is basically a pictorial representation which shows the relationship between input and output of any given physical system, correct? So, basically what is a block? Block is basically a symbol of block diagram which we are using, correct? So, When we are talking about block or block diagram, it is basically a symbolic representation which relates input given by us into the system to the output given by the system. Right? It relates input and output of our system. Correct? So let's just see how it looks. We are giving the input into our system. This is our block. Block refers to a system. Correct? Our given system. And this will be our output. So this is the entire representation of a block diagram. The next terminology which is quite essential to know and to understand is summing point. Whenever we are dealing with a block diagram, so what block diagram does is, it basically relates different system of and their interrelations, right? What it does, it shows you a pictorial representation of different elements of our system and how they are actually connected and how they work with each other. Correct? So in some time what happened that input given by us is taken by some of the portion of the system, and then from that particular portion or from that particular element output is given, and that output is then contributed to some another element of our system. So there are basically points where more than one or two elements can behave as input for our given system, correct, for our given element. So in that particular case, what we use is, we use a summing point. So summing point is basically a point where two or more signal can be either added or it can be subtracted to give you the desired results. Correct. So if you see here, this is the example of summing point. So as you can see that in one given point, there are three different points which are coming, or three different signals which are coming at one particular point, right? X, Y and Z. These are the three different signals which are coming in this particular summing point, and from this particular summing point output is going away from the system. So what will be the value of output when more than one signal is coming in one particular point? So in that particular case, we need to consider the sign, whether the sign of signal is plus or it is minus. Based on the sign of system, it will be performed. So if you can see in this particular figure, X is positive, Y is positive and Z is negative. Correct. So depending on the sign, we will perform action. So output we will be determining as X plus Y minus Z. So as you can see in this particular picture, X is positive, Y is positive and Z is negative. So the output which will be coming depends on these values. Correct. So we need to add X and Y since they are positive, and we need to subtract Z from the given values of X and Y to get the actual value which is coming out of the system. So this is how we can do. Suppose the value of X is 30, Y is 20 and Z is 10. So what will be my output? 30 plus 20 minus 10. So 30 plus 20 which is 50 minus 10 which is 40. So output coming from this particular point will be 40. Correct. Next point is basics of block diagram, which will be the next point is take off point. So what do we mean by take off point? The output signal can be applied to two or more points from the takeoff point. Takeoff point refers to that it may happen that from the one single point, two or more signal may go out. In that point, the value of signal can be written as like this. So this is our takeoff point. If you can see, values of Z is coming from this direction and it is then distributed in 3 different points. So the value of Z will remain as it is. Suppose the value of Z is 40. So it will be 40 in this line and in this particular point as well. Correct? So this is known as takeoff point. Next is forward path. So what do we mean by forward path? The direction of flow of signal from input to output. What we need to do is we need to start from our input point and move toward the output point. Whenever we are doing this way, whenever we are moving from input point to the output point, that flow line is known as forward path. Where we are considering the path here, flow path refers to how we are moving in a block diagram. So this is suppose our given block diagram. RS is our input, CS is our output. Correct. So what will be the direction of forward path? If I am moving from R to S, it is considered as forward path. Right. So forward path is given by R to CS, and this is the way or this is the path which is termed as forward path. Correct? Now let's see what is feedback path. We all know that whenever we are sending our output value to get measured and back into the system, then it is known as feedback system. So the path which is covering the feedback system is termed as feedback path. So feedback path is given by, if we are moving from CS to H1 and again to R of S, then it is considered as feedback path. Is it clear? Forward path, when you are moving from R to C, it is forward path, and when you are moving from CS to R of S, it is feedback path. Now next term is block reduction. Right, we have seen some basic terminologies which we will be needing to solve our numericals or to solve block diagram. But now we will deal with 8 rules which are being used to solve or to reduce any given block diagram. Basically, there are 8 different rules which are being used to determine reduction of block diagram or to determine overall transfer function of any given system. Correct? So, in that we will start with the first rule of our block diagram reduction technique. So, the first rule for block diagram reduction technique is, for blocks in cascade, gain of blocks connected in cascade gets multiplied with each other. So, what do it want to say? Gain of block. If the blocks are connected in series, we can simply multiply their transfer function to get the overall transfer function. Suppose this is my given input R of S. It goes into the block 1, which is G1. Output of G1 is R1S and it serves to be input for my next block G2. Correct? And G2 is giving me the final output CS. So, if you can see here, R of S is my input and C of S is my desired output. So, in between them, R1S is intermediate. Correct? So, what I want is CS, and if you can see, both the blocks are connected in series. They are connected in series. Right? So, what we can do to reduce this, if I want to reduce this particular block, I can simply write it in terms of G1 into G2. The simply multiplication of transfer function of both the blocks will give you the overall transfer function. Correct. So we can determine overall transfer function by simply multiplying both these blocks G1 and G2. So if you want to write down the overall transfer function for this block diagram, what you will be doing, you will first write transfer function for this section, that is G1 transfer function. So transfer function can be written as G1 equals to output upon input. It will be R1S upon R of S. So R1S can be represented as, R1S can be written as G1 into RS. So it is written as R1S equals to G1 into R of S. Right? Now, what you will do, you will write transfer function for block number 2, which is GS. So G2 equals to output upon input. G2, output of G2 is CS. So G2 equals to C of S upon R1 of S. Or I can write CS equals to G2 into R1S. What we will do, we will simply substitute the value here. So you will get the overall transfer function in the form G1 as G2S and R of S. Right. This is for this entire block diagram, and in simplified form we can directly write it as CS equals to output equals to G1 into G2 into R of S. Correct. So now let's see how it actually works. So suppose this is the given block diagram and you need to reduce this given block diagram. If suppose there are 3 different blocks G1, G2 and G3 which are connected in series. Right, this is your given input, this is your output, and G1, G2, G3 are 3 different blocks which are connected in series. So what we can do is, if we need to find the equivalent or overall transfer function for this given system, what we can do? We will simply multiply their transfer function. Right, we will write it as G1 into G2 into G3. So this will be our reduced form of transfer function. Coming up next is, suppose you are being provided with this kind of block diagram where input is R of S, then there is G1 and G2 which are connected in series. From G2 there is one bypass line, and after that there is G3, and finally there is CS which is your desired results. Right. So if you want to reduce this, how will you reduce this? Just tell. So to find its equivalent, what we can do is it equivalent to this? No. This is wrong. We cannot do G1 into G2 into G3. We can only do G1 into G2 just because G1 and G2 are connected in series. The value of G2 is then subdivided. Correct. So we cannot write it like this. So what is the correct method to write this block diagram? So this is the correct method to write this particular figure or to reduce this particular block diagram. Correct. So this is the correct way. RS equals to G1 into G2 because they are connected in series. The output of G2 is subdivided, so you cannot write it directly. You need to write it as it is and then G3 in this particular form. Correct. So this is all about what do we mean by block diagram, few terminologies which are related to block diagram, and we have also covered first rule of reduction technique. We will continue with the next rule in our next session. Hope all the things what we have done or covered today is clear. Thank you.